Okay, so you work this out as I asked you to do in the previous video. So let's see how this goes. You have the integral along a curve of x squared plus 2y dx plus the horizontal component dx in x direction plus xy, which is the vertical component xy dy from 0, 0, coordinates 0, 0 to the coordinates 1, 4. Alright? So let's see how this goes. Here we're integrating along the curve of x squared plus 2y, but hold on, we're going to change a function of x and y to a function of x only by substitution. Here we see that y is 4x squared, so that's what we're going to substitute. So instead of putting y, we put 2 instead of 2 times y, we have 2 times 4x squared dx plus xy. Oh, we have y again. We need to change that y to 4x squared. X times 4x squared dy. But hold on again. This dy should be changed to dx. How we do that? Well, we have the function y is equal to 4x squared. Now, dy by dx is equal to 2 fours 8x. Now, this implies that dy is equal to 8x dx. Good. So we know what dy is now. So this dy business, it is 8x dx. So it is 8x dx. Alright? Now we know it's integral along a curve of a function of x dx. x1 is 0 and x2 is 1. So we're going from 0 to 1. So we can put that on the integral sign now, from 0 to 1 of, so we have x squared plus 2 fours 8x squared dx plus 4 that. This is x squared times x, which is x to the 3, times x again, which is x to the 4th, x to the 4th. So this is, so we have 8 times 4, which is 32. So it's 32 x to the 4th. So it is 32 x to the power of 4 dx. Right? So we integrate all of this. So you have the integral from 0 to 1 of, putting everything together. This would be what now? This would be 32x to the 4th. Well, we have an 8x squared plus a 1x squared, so we have plus 9x squared. Right, that's it. Dx equals, okay. Then we do our integration now. 32x to the 4th. This will give 32x to the 5 over 5 plus 9x cubed. This will be 9x squared, which is going to become 9x cubed over 3. And we're going from 0 to 1. Okay. So here, this is 32x to the 5 over 5 plus 3 to 3, 1, 3 to 9, 3 x cubed from 0 to 1, which is equal to, we substitute 1 first, 32 times 1 to the 5, which is just 1, over 5 plus 3 times 1 cubed, which is 1, okay, minus 32 times 0 to the 5 over 5, which is 0, plus 3 times 0 cubed, which is 0. Okay, so that amounts to 0, alright? So 32 divided by 5 plus 3, what does that give us? Let's take our calculator. It's going to be 32 over 5 equal plus 3 equals. Okay, so we have 9.4. So this is 9.4. Alright, good. Then we're going along y equals 0 and then x equals 1. So let's see what will happen there. We're supposed to go from 0, 0 to 1, 4. The part that we just did a while ago, the curve, I expect to look somewhat like this, 4x squared, yeah? 4x squared, it goes this way. But the second part, this is part A, the second part, it goes along y equals 0, which is the x-axis, and then x equals 1. So we would move along the x-axis. Remember, the coordinates would be what again? It would be 0, 0 to 1, 4, right? So it would be 4 up here, 1 here. So if we do that, go along y equals 0, which is the x-axis, we would go straight across to 1. And then along x equals 1 means we go straight up and end up at 4. Alright. Now, the function we have is integral of x squared plus 2y dx plus xy dy. Integral of x squared plus 2y dx plus xy dy. And we're integrating all of this along the curve. Now, we're going from 0, 0 to, this will be 1, 0, along the x-axis, which is y equals 0. Alright. If we go straight across, then the thing is, what is y? Think about it. What is y and what is dy? Well, when we go straight across, y is 1, because after all, remember, it says along y is 0, because after all it says y equals 0, right? It's the x-axis, so y is equal to 0. dy, if you have a dy, there would be a change in the vertical going up or down, but there's no change in the vertical, so dy is also 0. So when you do this, you are integrating from, now here, you're going from, only dx would work out, you know, because dy is 0, so you'd have only a dx and y is 0 too. Let's set up the equation first. This is x squared plus 2y, but y is 0, 2 times 0, but 2 times 0 is 0, so it's just x squared dx. So this reduces to x squared dx plus y is 0, So it's x times 0, which is just 0, times dy is 0. So this part is gone. So you're looking at x squared dx. Now x move from 0 to 1. So you're integrating from 0 to 1. Make sure you see that. Alright? So that's what happened in that particular case. So this is equal to, when you integrate x squared become x cubed over 3 from 0 to 1, which is 1 cube, which is 1 over 3, minus 0 cube, which is 0 over 3. But 0 over 3 is just 0. So that part amount to 1/3. Alright. So we went from 0, 0 to 1, 0 along the x-axis, which is y equals 0. Now let's move up from 1, 0 to 1, 4 along x equals 1. So from 1, 0 to 1, 4 along x equals 1. Let's see what happens in that case. When we move straight up, x is 1. Okay. So x is equal to 1. A dx would mean a shifting left or right, but there is no left or right movement, it just goes straight up. So that dx is 0. So dx is equal to 0. Alright? So we're working with only y and dy now. So here we're integrating along the curve of x is 0, or x is 1, so it's 1 squared, which is 1 squared plus 2 times y plus 2y dx, but dx is 0. Alright? That would all reduce to 0. Plus xy, but x is 1. So this is 1y, which is just y. So I can write the y nearer to here, the plus sign. dy. dy, there's a change in y, so it's dy. Alright, so this is equal to the integral along the curve of 2y. Oh, this is reduces to 0. Everything here is 0. Alright, plus y dy. Alright, along y dy. But y moves from 0 up to 4. You see that? It's actually from 0 to 4. So we integrate from 0 to 4 of y dy. What do the integral? Let's say y squared over 2 from 0 to 4. Now, that will give us 4 squared over 2 minus 0 squared over 2, which is 16 over 2, which is, I have 8. Alright, my. We run out of scrolling space. Let's draw a line here and finish up at this point. So here now, the integral, let's call it I, is equal to in the x direction, we have 1/3. So this is 1/3. And in the y direction, we have 8. Oh, let me write this further down and draw the graph beside it. The integral, let's call it I, is 1/3 plus 1/3 in the x direction plus 8 in the y direction, right? So 1/3 plus 8, which is 8 and 1/3. Alright? Now 8.333 and so on, but 8 and 1/3. What did we get for part A again? Is it working for part A? My. Did I erase it? Oh, 9.4. So part A gives 9.4. 9.4 would be like 4/5, right? 4/5. Oh, no man, 6/5. No. 2/5, 2/5, right? It's 9 and 2/5. So A gives 9 and 2/5. B gives 8 and 1/3. So here, what we found is that integrating from 1 to another along different path do not necessarily produce the same results. All right, so integrating from one point to another along different paths do not necessarily produce the same results, right? So here we have one path going this way and the other path, so we went this way and then we went here and then here. We end up the same place, but they don't necessarily produce the same result, right? So in this case, the results were different. Now, in future videos, maybe the next video, we're going to see a certain situation where it will not matter which path you take, they will produce the same results. Now, in those examples, we'll look at what you call exact differential. Alright? So we'll look at exact differential in those examples that we'll look at. So I'm going to see you in those videos where we start looking at exact differentials.